Before we move on, I want to talk about one other topic. I don't think this is in your book, but it's going to come up a little bit later as we talk about uh, the delivery of medicine through breathing treatments, where you have something called the Venturi effect, and it's something called the Bernoulli Principle. Bernoulli's principle is based on the conservation of energy. We'll talk about conservation of energy next time, but it basically says that energy is conserved, that you can't lose, you can't create or make energy. Conservation of energy. Based on this, Bernoulli's principle is based on this at its very core. And one of the outcomes of the Bernoulli principle says that in a flow of a fluid, if, or let's see, the pressure is inversely related to the velocity. So what that means is if the velocity goes up, so say for example in your water hose, when you put your finger over the end of the water hose and it comes out faster per the equation of continuity, remember we talked about that, if the area gets smaller, the velocity increases. If you increase the velocity, you might think, well, the pressure should increase, right? In fact, you might even feel that in some sense where the water is hitting you and it feels like it's hitting you at a bigger pressure. But in fact, the pressure is decreasing. It has to do with the mass flow rate. There's just less pressure being imparted to you. So the Bernoulli principle says that if the velocity goes up, the pressure goes down. And we'll see this. I'll go ahead and give you a little preview where let's say you have a container here of medicine. There's some particles of medicine here that you want to deliver to your patient. And so you hook them up to this breathing tube, and they're going to be down here. We know that I'm really good at drawing mouths. There they are. They have a very large mouth, and they're breathing into this tube, right? Um, and so you want to get this medicine into their lungs. And the way you do it is you put a high velocity stream of air. And when I put a high velocity stream of air, because the velocity has gone up, now this is a low pressure. So all along here I have a low pressure, but here I have a high pressure. So those little particles of medicine are going to get sucked up and then they'll travel down to your patient. So that's the Bernoulli's principle. This is also the concept behind airplane wings. So airplane wings look like this, and then when you have air traveling over them, you have one stream of air that goes over the top. That's the long way, so that's a high velocity stream of air. And then on the short side, I have a low velocity stream of air. So that means that I have a low pressure over here and a high pressure over here, and that gives me lift. So Bernoulli's principle is also the concept behind airplane wings, and I'll show you some demos from that, and I'll include a video on the Bernoulli's principle in the links.